What is a matrix? A type of biological cell. B. A rectangular array of numbers. C. A type of medication. D. An organ in the human body. The correct answer is B. A matrix is a rectangular array of numbers arranged in rows and columns. What is the transpose of a matrix? A. Swapping rows and columns of a matrix. B. Adding all elements of a matrix. C. Multiplying all elements of a matrix. D. Negating all elements of a matrix. The correct answer is A. The transpose of a matrix involves swapping its rows and columns. What is the determinant of a matrix used for? A. To perform operations on matrices. B. To determine invertibility and solutions to linear equations. C. To represent a biological process. D. To track drug distribution in the body. The correct answer is B. The determinant of a matrix is used to determine invertibility and solutions to linear equations. What is the adjoint of a matrix? A. A diagonal matrix. B. A matrix obtained by swapping rows and columns. C. A square matrix obtained by taking the transpose of the cofactor matrix. D. A vector with elements representing the main diagonal of a matrix. The correct answer is C. The adjoint of a matrix is a square matrix obtained by taking the transpose of the cofactor matrix. What is the inverse of a matrix? A. A matrix with all elements being zeros. B. A matrix that when multiplied with the original matrix gives the identity matrix. C. A matrix with all elements being ones. D. A square matrix obtained by swapping rows and columns. The correct answer is B. The inverse of a matrix is a matrix that, when multiplied by the original matrix, gives the identity matrix. How are matrices used in pharmacokinetics? A. To study chemical reactions. B. To model drug absorption, distribution, metabolism, and excretion. C. To determine patient compliance with medications. D. To analyze genetic mutations. The correct answer is B. Matrices are used in pharmacokinetics to model drug absorption, distribution, metabolism, and excretion. What does it mean for two matrices to be equal? A. They have the same number of elements. B. They have the same dimensions and corresponding elements are equal. C. Their determinants are equal. D. Their elements sum up to 1. The correct answer is B. Two matrices are equal if they have the same dimensions and their corresponding elements are equal. What operation is performed when adding two matrices? A. Multiplication. B. Subtraction. C. Element-wise addition. D. Transposition. The correct answer is C. When adding two matrices, an element-wise addition is performed on corresponding elements. What is the application of matrices in pharmacokinetics? A. Determining the dosage of a drug. B. Modeling drug distribution in the body. C. Calculating drug half-life. D. Predicting drug interactions. The correct answer is B. Matrices are used in pharmacokinetics to model drug distribution in the body and study how drugs move and interact within the system. What is the result of multiplying a square matrix by its inverse? A. 4. B. Identity matrix. C. Zero matrix. D. Transpose matrix. The correct answer is B. Less than break time equals 1s greater than. When a square matrix is multiplied by its inverse, the result is the identity matrix. This is a square matrix with ones on the diagonal and zeros elsewhere. In matrix multiplication, the number of columns in the first matrix must equal what? Number of rows in the second matrix. Number of columns in the second matrix. Sum of rows in the second matrix. Sum of columns in the second matrix. The correct answer is A. Less than break time equals 1s greater than. For two matrices to be multiplied, the number of columns in the first matrix must equal the number of rows in the second. What is the inverse of a matrix used for solving linear equations? A. Determining if a matrix is square. B. Checking for symmetry in matrices. C. Solving systems of linear equations. D. Finding the determinant of a matrix. The correct answer is C. The inverse of a matrix is used to solve systems of linear equations by multiplying the inverse of the coefficient matrix with the constant matrix. What is the solution of a linear equation system with a non-zero determinant? A. Infinite solutions. B. Unique solution. C. No solution. D. Dependent solution. The correct answer is B. If the determinant of the coefficient matrix of a linear equation system is non-zero, there exists a unique solution for the system. What matrix operation is performed when finding the adjoint of a matrix? A. Addition. B. Subtraction. C. Transposition. D. Scalar multiplication. The correct answer is C. The adjoint of a matrix is found by taking the transpose of the cofactor matrix. This involves interchanging rows and columns of the original matrix. What is the primary use of determinants in matrix calculations for pharmacokinetics? A. Determining total drug dosage. B. Evaluating drug bioavailability. C. Calculating drug clearance rates. D. Assessing drug elimination mechanisms. The correct answer is C. Determinants in matrix calculations for pharmacokinetics are primarily used to calculate drug clearance rates, which influence the rate at which a drug is removed from the body. Which type of matrix has the same number of rows and columns? A. Identity matrix. B. Rectangular matrix. C. Square matrix. D. Zero matrix. The correct answer is C. A square matrix has an equal number of rows and columns. It is denoted by the format n by n, where n is a positive integer. What is the primary purpose of using matrices in pharmacokinetics modeling? A. Studying drug metabolism. B. Solving linear equations. C. Modeling drug concentrations over time. D. Analyzing receptor binding. The correct answer is C. Matrices are used in pharmacokinetics to model drug concentrations over time, aiding in the understanding of drug distribution and elimination. How is the determinant of a matrix related to solving linear equations in pharmacokinetics? A. Determinants indicate whether solutions exist. B. Determinants affect the rate of drug elimination. C. Determinants signify drug potency. D. Determinants represent drug half-life. The correct answer is A. Less than break time equals 1s greater than. In pharmacokinetics, if the determinant of the coefficient matrix is non-zero, it indicates unique solutions for the system of linear equations modeling drug processes. When finding the inverse of a matrix, what property must the matrix have to be invertible? A. Zero determinant. B. Non-zero determinant. C. Square matrix. D. Rectangular matrix. The correct answer is B. The determinant of an invertible matrix must be non-zero. Otherwise, the matrix is singular and has no inverse. In pharmacokinetics, how are matrices effectively used to monitor drug distribution in different body tissues? A. Calculating drug absorption rates. B. Modeling drug concentration gradients. C. Measuring drug half-life. D. Predicting drug receptor interactions. The correct answer is B. Matrices can be used to model drug concentration gradients in different tissues. This helps us understand drug distribution and predict drug levels over time. What is the result of multiplying a matrix by its inverse? A. Identity matrix. B. Zero matrix. C. Square matrix. D. Determinant matrix. The correct answer is A. The result of multiplying a matrix by its inverse is the identity matrix. This property is crucial for matrix calculations and solving systems of equations. Which matrix operation is key to figuring out how drug metabolism affects drug levels in pharmacokinetic studies? A. Transpose. B. Inverse. C. Determinant. D. Multiplication. The correct answer is D. Matrix multiplication is essential in evaluating the impact of drug metabolism rates on drug concentrations over time in pharmacokinetic studies, aiding in drug efficacy assessments. In pharmacokinetics, matrices represent which system characteristic? A. Drug concentration over time. B. Body weight fluctuation. C. Immune system response. D. Heart rate variability. The correct answer is A. Matrices are used in pharmacokinetics to model drug concentration changes over time. What is the primary objective of solving linear equations using matrices in pharmacokinetics? A. Predicting drug metabolism rates. B. Estimating drug concentration profiles. C. Analyzing tissue distribution efficiency. D. Determining drug elimination pathways. The correct answer is B. The main purpose of using matrices in pharmacokinetics is to estimate and analyze drug concentration profiles over time. In pharmacokinetics, how are matrices used to study drug distribution in different body tissues? A. Modeling drug elimination pathways. B. Simulating drug metabolism rates. C. Analyzing tissue compartmentalization. D. Estimating drug concentration changes. The correct answer is C. Matrices are used to compartmentalize body tissues and study drug distribution within them. How do matrices help study drug elimination processes in pharmacokinetics? A. By determining the transpose of matrices for elimination rate calculations. B. By finding the solution to linear equations representing elimination rates. C. By using matrices to model drug distribution and elimination processes. D. By calculating the determinant of matrices for drug elimination rates. A. None of the above. The correct answer is C. Matrices are used to model drug distribution and elimination in pharmacokinetics. This helps us understand how drugs are metabolized and eliminated from the body. In pharmacokinetics, how are matrices applied to monitor drug distribution within body tissues? A. By calculating the inverse of matrices to assess drug concentrations. B. By studying drug metabolism rates through matrix multiplication. C. By representing drug concentrations in different tissues using matrices. D. By finding the adjoint of matrices to analyze drug distribution differences. A. None of the above. The correct answer is C. Matrices are used to represent drug concentrations in various body tissues in pharmacokinetic studies, allowing researchers to monitor and analyze how drugs distribute within the body. How are matrices effectively used in studying drug distribution within different body tissues in pharmacokinetics? A. By calculating matrix inverses for drug concentration assessments. B. By finding the adjoint of matrices to analyze drug distribution differences. C. By representing drug concentrations in tissues using matrices for monitoring. D. By studying drug metabolism rates through matrix multiplication. A. None of the above. The correct answer is C. Matrices are effectively used in pharmacokinetics to represent drug concentrations in different body tissues, enabling researchers to study and monitor drug distribution patterns. What impact does matrix inversion have on solving linear equations in pharmacokinetic studies? A. Matrix inversion helps analyze drug metabolism rates in linear pharmacokinetic models. B. Matrix inversion ensures the system of equations has a unique solution. C. Matrix inversion improves drug distribution analysis in pharmacokinetics. D. Matrix inversion is essential for calculating determinants in linear equation systems. A. None of the above. The correct answer is B. Matrix inversion is crucial in pharmacokinetic studies. It ensures that the system of linear equations has a unique solution. This aids in determining accurate drug concentrations and distribution rates. How do matrices in pharmacokinetics help us study how drugs leave the body? A. By calculating matrix inverses to assess drug elimination rates. B. By using matrix transposers to represent drug elimination rates. C. By modeling drug distribution and elimination using matrices. D. By finding matrix adjoints to analyze drug elimination differences. A. None of the above. The correct answer is C. Matrices in pharmacokinetics are used to model drug distribution and elimination. This helps researchers understand how drugs leave the body and their levels in different tissues. What type of matrix has the same number of rows and columns? A. Square matrix. B. Identity matrix. C. Diagonal matrix. D. Symmetric matrix. The correct answer is A. A square matrix has the same number of rows and columns, making it an important matrix type in various mathematical applications, including pharmacokinetics. What matrix operation is key to understanding how drug metabolism affects drug levels in pharmacokinetics? A. Matrix addition. B. Matrix multiplication. C. Matrix transpose. D. Matrix inversion. The correct answer is B. Matrix multiplication is an integral operation in assessing how drug metabolism rates impact drug concentrations in pharmacokinetic studies. It allows researchers to analyze complex relationships within the system. How are matrices effectively used in studying drug distribution within different body tissues in pharmacokinetics? A. By calculating drug elimination rates. B. By representing drug concentrations. C. By determining drug metabolism pathways. D. By analyzing drug absorption levels. The correct answer is B. Matrices are effectively used in pharmacokinetics to represent drug concentrations within different body tissues, enabling researchers to study drug distribution patterns. In pharmacokinetics, how are matrices used to monitor drug distribution in body tissues? A. By calculating drug elimination rates. B. By representing drug concentrations. C. By determining drug metabolism pathways. D. By analyzing drug absorption levels. The correct answer is B. Matrices are used in pharmacokinetics to show drug concentrations in body tissues. This helps researchers track how drugs spread throughout the body. What impact does matrix inversion have on solving linear equations in pharmacokinetic studies? A. No impact. B. Multiple solutions. C. Unique solution. D. Inconsistent solution. The correct answer is C. Matrix inversion in pharmacokinetic studies typically leads to a unique solution for linear equations, providing researchers with accurate solutions to complex mathematical models.